Look up here at this map of the Hoover Dam area, we're going to talk about the construction of the dam. The yellow line here represents where we just came from. We started here at the elevators, walked up this way, and we're right now inside this diversion tunnel. This whole tunnel here, this whole thing is what they used to move the Colorado River out of the way of the work area with. They did that by constructing 4 of them, 2 on the Nevada side and 2 on the Arizona side. These diversion tunnels are 50 feet in diameter and about 4,000 feet long, or 3/4 of a mile. They were put in by blasting through solid volcanic rock over a period of about 2 years. Once those were constructed, we built temporary dams, also known as coffer dams. They're just big mounds of rock and dirt about 100 feet tall that sat on the bottom of the riverbed. Their job was to direct all that water into the diversion tunnel and away from the construction area. The lower stream coffer dam just prevented that water from backfilling into the work site, and that's what gives them that dry riverbed where they can begin their job. First thing they would do is remove about 135 feet of material down to the solid bedrock. It's the solid bedrock that gives that secure foundation where they can build a wall. So the first thing they would do is start dropping large buckets of concrete. Each bucket is 8 cubic yards. So think of it like one of those large cement mixing trucks you might see on the road today. They dropped one of those every 90 seconds, 24 hours a day, 7 days a week for almost 2 years. That's 6.6 million tons of concrete. It's enough concrete to pave a road all the way from San Francisco to New York City. Now once we've constructed the wall, we start to fill the lake. Before we do that though, we need to plug up the 3 diversion tunnels. The gray areas represent 420 feet of concrete they put into each tunnel. This outer tunnel stays open at that point. It allowed the river to continue its course downstream as the lake is filling with water. And in the last year of the project, we built the intake towers, 2 on the Nevada side, 2 on the Arizona side. They are 395 feet tall. They sit about 250 feet up off the bed of the lake. As the water starts to rise, it flows down into the tower, then it goes into a large pipe called a penstock. If you look through that window, you'll see the penstock pipe. It is 30 feet in diameter, and water is actually flowing through it under your feet at about 180,000 gallons per second. To give you guys an idea how much water that is, you can fill an Olympic-sized pool in about 3 seconds. Now as the water flows through there, it branches off into these smaller pipes and goes down to these red dots here that represent the generators. The water flows through those, spins the turbines, that creates electricity, and then the water will shoot out into the tail race bay here between the 2 plants and back out into the river. That lower stream coffer dam is removed by blasting it out of the water. Once that happens, it allows the river to continue its normal course back downstream, and this 4th and final tunnel is then plugged as it's no longer needed. The outer tunnels were repurposed. They were turned into what we now call the Nevada-Arizona spillway, or the flood control system. So if the lake ever overflows, they don't want that water to go over the top of the dam. That would cause all kinds of problems for a power facility. So they figured out a way for all that flood water to leave the lake and enter these tunnels, and then travel through the canyon walls, exiting back into the river, bypassing that facility altogether. Now these were used twice, once in 1941 as a test, but in 1983 we had a series of snowstorms in the Rocky Mountains, a sudden heat spike, all that snow melts suddenly, and that causes Lake Mead to overflow for 67 consecutive days. If you look at this photograph here, this is our lake in 1983, and at the back of the photo you can actually see that year that the water rose to just 7 feet from the top of the dam. But then it flows down 26 feet into our spillway tunnel. It goes through a large gate known as a drum gate, and then all that water will just travel through the canyon walls, back into the river, bypassing that facility safe and sound. The final thing to mention is the volume of water that went through there that year is the same volume of water that comes out of Niagara Falls. So it was one serious flood. And while it didn't do any damage to the power facility, once all that water enters back into the river on that end, causes that to overflow, then it completely washes out the Imperial Valley in Southern California. All right, folks, that's going to do it for this part. We're going up now to the power plant. We're going to check out the generators. We'll be using 2 lifts to get you guys out there. So if you're in a group or a family, stick together if you want to be in the same elevator together. Unless you don't, we can make that work too. But let me get out here in front and I'll lead us down the tunnels.